Hey there, my name is Rohit Kumar, and today we are going to discuss another very important research topic, which is parallel computing. So let's start. So as you can see that lot of diagrams you can see here, and all these diagrams are related to the parallel computing. In parallel computing, when we discuss, then different sort of things come into mind, like cluster computing, distributed computing, and sort of things. But parallel computing gives you a different sort of phenomena, and this phenomena assures you to have some sort of parallelism in the computation or some sort of parallelism in terms of architecture, and that's why you achieve the parallelism in computation also. So when we say parallel computing, exactly it points out to a type of communication where multiple computations or the processes are carried out simultaneously, and in this way the large problems could have been handled in a better way, because you can subdivide the problems into smaller parts, and then you can further achieve the computation at the discrete multiple nodes level. And in this way you can then combine the solutions together, and then you can have the final solution. Means break and solve type of model you can take into consideration, and then you can achieve the concept of parallel computing. Now, point is that when you are discussing this sort of concept, then many people do say that what are the different sort of components or the things related to this particular thing. So one very obvious and popular thing, that task parallelism will come into picture, and you may have the different sorts of things, that bit level computation, instruction level, or the task level computation. And the concept of high performance comes into picture, because parallel computing obviously going to boost your performance, and that's why you are going to achieve the concept of high performance computing. Then if you have the multi-core systems, so again means it will be easy to assign the subdivided tasks to multiple cores, and in this way the multi-core systems make your task easier. Then the concept of distributed computing gets related, because the physically if the resources are distributed, means though the network is distributed but they are logically connected, and in this way you can distribute your task over to the physically distributed machines. And inter-process communication means the OS concept which comes into picture again, because multiple process means the subdivided processes do communicate with each other, do transfer the data to one another, and in this way some sort of cascading they do perform, and means the one component's output may drive the input of other component, and so on. So different sorts of possibilities and functionalities are possible, and in this way you can achieve the concept of parallel computing. But when people say that what exactly the concept of parallel computing, and what are the sort of backgrounds, then a lot of means components do come into picture related to the distributed computing, related to operating system, related to architecture, and then the issues like the mutual exclusion sort of things, then synchronization, and the parallel processing, and the computation, and the hardware related aspects do come into the picture. And finally, when dealing all these sort of technical issues at the ultimate level, what is the output, means what is the application level, where do you are you going to apply it, and multiple sort of parallel wherever you can apply your parallel computer, or the sort of supercomputers or the multi-core computers systems, then everywhere you can apply this concept of parallel computing. And that's why some parallel programming languages have also been developed, and they have been in under development also. So you can go for the history and the related software algorithmic history related, and sort of background exploration related link, and you can explore further by going on to the relevant links and sites. And if required, then please comment down below, and I will also make you to find some of the related good links. Now, coming to some of the basic research topics, because this particular series of research domain and topic we have started for the fresh researchers who are going to start their first research course, and they are not much familiar with research domain. So this particular series is going to help you with some of the latest topics, and the most important topics might not be necessarily the latest, okay, because the parallel computing is not a new concept. It has been widely used since long. So let me tell you that more than 190 countries have been using the concept of parallel computing, means almost every country is using the concept of parallel computing in some way, and more than 220,000 researchers have been actively engaged in the things or the task or the kind of research related to parallel computing in one way or the other. Okay, now when we say that these statistics, then obviously these statistics may vary with time and it might be wrong because we have also got these statistics from internet and some source. But point is that the domain or the usefulness or the kind of application of parallel computing has that nobody can deny the fact that it's a very prominent field to research. Now coming to the point that what are the research topics or the related topics, then there are multiple things. But one common thing that parallel algorithms are there, because when you are saying parallel computation, parallel computing is there. So obviously the design of parallel algorithms is the must need. And when we are going for that, then software related aspects you need to discuss. You need to discuss, for example, in big data, the map reduce concept you must have heard of. And that particular concepts are also working in similar fashion. Means you firstly divide the things into multiple chunks, and then you map onto the respective processing units, and then you means reduce the computational state, and then you collect all the solved parts, and then you create the wholesome solution. So coming to these sort of things, multi-core processor, parallel algorithms do come together, and they make this happen, the concept of parallel computing. Additionally, the fault tolerance, the data flow management, the multiprocessing distributed computing, sort of the role of supercomputers in parallel computing, and how do you achieve the speed up, and the concept of MIMD, means multiple instruction, multiple data, and sort of computer engineering, and what is the difference or what is the performance improvement in comparison to the traditional computing. So all these sort of domains do come into picture. You can go into their subdomains or their subtopics, and then you can go for research. Okay, now coming to the companies, so obviously whatever be your either it's a entertainment, multimedia, or sort of some industrial company, or some sort of audio video processing, every sort of company is going to have the concept of big data, because so much data is nowadays available, and every company is going to handle it in an efficient way, because ultimately they want to get some sort of useful network or the information heuristic, and that heuristic is supposed to guide or govern the future improvement in the process. Then this sort of concept, means parallel computing or the role of supercomputer or the multi-core systems, it becomes very, very important. So you can consider that how wide the scope of parallel computing is. Now coming to the usefulness, so obviously so many, considering it, their usefulness, so many private as well as the public agencies have been in the funding, and the related bodies have been involved. And if you want, then you can contact the national as well as the international bodies, including the National Cancer Institute, the European Commission, National Library of Medicine, National Heart, Lung and Blood Institute, and National Institutes of Neurological Disorders and Stroke. Means multiple medical related agencies, the government agencies as well as the defense agencies, the law agencies, academia, etc. So many different institutions are involved. And if you want to have the sort of industrial support, then you may contact it to IBM, Microsoft, Google sort of companies, and they have their dedicated research wings available for this sort of options and the opportunities. So you can go and join their R&D centers, or you can ask for the related funding if you want to maintain a sort of MOU with them, or you want to, means if you are big in reputation, then obviously if you are a kind of individual researcher and want to perform your individual research, then you may ask for the related support in terms of some paper publication, in terms of some conference publication support. You can go have propose your proposal, and then you can ask for kind of contribution. So in this way you can go and look for the opportunities. But point is that if you don't have the opportunities, still it is fine. You can go for some unpaid journals. Multiple journals are available, and then you can make the world look onto your type of research that you have produced. And in this way, some of the related journals include IEEE Transactions on Computer, Microprocessors and Microsystems, ACM SIG Plan Notice, ACM SIGARC Computer Architecture News, then the Journal of Parallel and Distributed Computing, IEEE Transactions on Parallel and Distributed Systems, then Parallel Computing, Concurrency and Computation Practices and Experiences, Journal of Physics Conference Series, then IEEE Access, Journal of Supercomputing, and the IEEE Transactions on VLSI Systems, International Journal of the Computer Applications, Picture Generation Computer System, the International Journal of High Performance Computing Applications, advanced materials research, IEEE transactions on computer-aided design of integrated circuits and systems, and so many others. Okay, so these are just 8 to 10 journals I have quoted. Additionally, you may find a lot more journals. You can explore the public databases, including the Google Scholar, etc. There you'll find the related journals as well as the related authors links. So when you'll come into the domain, you'll get to know that in addition to the IEEE, ACM, Elsevier, etc., you may have multiple other publishers, including the Springer, Violet, Learn, Francis, Pi, Sage, IOP Publishing, Transtech, EnderScience, etc. Okay, and all these publishers have been actively involved in publishing the research related to parallel computing. Now coming to the open access or non-open access. So as I told you that if you do have some sort of funding available at your side, you can go for the open access to have a wider coverage of your research. But if it's not, then obviously you can go for the traditional subscription based publishing. And obviously if your content has some sort of merit, then definitely your content is going to be wide and popular. Now coming to the point that here we discuss that, and before continuing further, one point also want to make clear, because it is very common myth, that if your work doesn't have much citation, it doesn't mean that your work is not relevant, because in making or getting more citations, then it's a totally different game. People do write citation, means review papers, people do write the open access papers, people do publish in open access journals, means, and people do have a lot of contacts, etc., to publish or to make their work go wide, and sort of practices are there. So point is that you might be single, you might be independent researcher, you might be working alone, and you don't have funding at your side to make the work open access, and you are working in a very defined field or area, and that's why so many researchers are not actively working in that domain. You might be working on a very new technology, and very limited researchers have been equipped with the such courage to delve into that very fresh area of research. So don't worry, means if your work didn't get any citation, if you are satisfied, your reviewers are satisfied, your work has been published, in future, not today, but in future, people will get and notice your work. Okay, now come to, because mostly people get depressed due to the fact that the citations are not coming. That's a totally different game. Now coming to the most of the citation related citations, then I'm going to tell you some of the related citations. Why? Because when we go for publishing, we think that which journal is suitable. Additionally, which are the topics or the contents that we should have a focus on. Thirdly, that what are the current focuses of a particular engineering or a research stream, because time to time the focus of any field gets changed, and over the period of time some new technologies do come, and then with a mix of new advanced technologies as well as the focus of the current field, you can come up with some new solutions or the kind of ideas. So let me tell you that in International Journal of Cloud Computing in 2023, they have accepted a kind of early access work, and the work discusses the enhancing the title is the enhancing the job scheduling procedure to develop an efficient cloud environment using near optimal clustering algorithm. Okay, so here you can see that clustering algorithm they have proposed, which is optimal in a way using the for developing the efficient cloud environment, and they are aiming to enhance the job scheduling processor. Okay, then in ACM computing surveys, they have accepted a work which is early access. So title is the query processing on heterogeneous GPU or CPU systems, and again multiple CPU or GPU systems. So in this way, the parallel computing is obviously been there. Then the comprehensive exploration of languages for parallel computing is presented as early access in ACM computing surveys. Then the Chinese Journal of Aeronautics has accepted a 2022 work in the form of a review on fault-tolerant cooperative control of multiple unmanned aerial vehicles, UAV work they have discussed. Then the decision support systems has accepted a work in 2022 titled The Impact of Hierarchical Privilege Levels and Non-Hierarchical Incentives on Continued Contribution in Online Q&A Communities, means question and answer communities, a motivated model for gamification goals. Okay, so they have focused on the gamification goals, and in this way they have discussed with the hierarchical privilege levels and the non-hierarchical incentive-based continuous contribution in online and communities or the environments. Now coming to the other work, so SWAM and evolutionary computation based work has been accepted in this particular journal named the Surrogate Assisted Population Based and Colony Optimization for Resource Constrained Job Scheduling with Uncertainty. Lot of uncertainty have also been present in the procedures, and that's why there are so many constraints related to the uncertainties, and based on these constraints you need to design some sort of optimal solution. So here they have used the end colony optimization, very well known optimization technique, and they have used the concept of surrogate, and that's why the processor is surrogate assisted. Okay, now coming to the other work, so computer communications, very well known elsewhere journal. This 2022 work, which is listed as SaaS, means software as a service parallel task scheduling based on cloud service flow load algorithm, has been discussed. Additionally, the Chinese Journal of Aeronautics in 2022 has discussed the accelerated Land-Weber iteration-based control allocation for fault-tolerant control of resilient launch vehicles. Point is that there are so many domains, there are so many topics, there are so many technologies, and there are so many things that you can focus on or have a well mix of all these things to work in a particular field. And again, as I always tell, that any field is going to be part of multiple interdisciplinary fields, and that's why you are going to relate with some more fields. So with respect to parallel computing also, you may go into the field of cloud computing also, you may go into the field of supercomputing, you may go in the field of aeronautics, you may go in the field of decision support system, you may go in the field of evolutionary computing, you may go in the field of song computing, you may go in the field of normal computer communication, you may go in the field of UAVs, means unmanned air vehicles, you may go in the field of sustainable computing, you may go in the field of software engineering techniques, you may go in the field of integrated circuits and related parallel computation in embedded system. So sort of multiple domains are there, and then you can explore the possibilities according to your need and the focus of your research. So I'm going to close this video. Please tell me, how did you like this video? If not, then what are the related things that you didn't like? What are the things that were not covered? And please do criticize the video in terms of comments. Please let me know. I will try to learn from your comments, and will try to incorporate the things in my future video analysis. Thanks for watching it. Thanks again. Happy learning.